if exactly one variable is solved for, only one, it doesn't even matter if it's x or y, or sometimes it'll be a and b or c and d. They don't have to be x and y, but if one of your variables is solved for, then that's when you want to use substitution method. It doesn't matter which one, but if one letter, whether it be x, y, whatever, is by itself on the side of an equals, and only one, that's when substitution method is preferred. And let me show you why. Here's all you have to do for substitution method. You have to solve for a variable, which is already done for us here, x equals. It's solved for. And you're going to take what it equals, and you're going to plug that in for the x on the other equation. So, if x equals 2y, then I can rewrite my second equation as 4, but instead of x, I'm going to plug in 2y, because that's what x equals, plus 2y equals 15. Now this I can solve for y. So that's 8y plus 2y equals 15. 10y equals 15. Divide by 10. And what is that going to give you for your y value?
1.5.
Yeah, 1.5 or 3 halves, 1.5, however you got it. I prefer fractions, so I'm going to do 3. But I think behind that box it says 1.5. Now, if y is 3 halves, how can we get x?
Plug it back in.
Yeah, just plug it back in. Right there. Just plug this in for y and see what x equals. So that means x is going to equal 2 times 3 halves. We're just plugging this in right there. And then the 2's cancel, and you're left with x equals 3. So your solutions are just like yesterday. These are the same exact problems. The only difference is we're not graphing them. That doesn't mean they can't be graphed. If you were to graph those, guess where they'd cross? They'd cross at the point 3 halves.
So our answer today should be in like a
Coordinate, just like yesterday. In fact, just like yesterday, you still want to put consistent, independent, and all that stuff. So this one would be 3 halves, which would be consistent, independent.
wait, what? How do you decide what it is?
What?
That confuses me. Like, what do you mean 3 and 3 times?
Well, do you get where these points came from yesterday?
Yeah.
It's just where they cross, right? That's what we just solved for, algebraically, instead of graphing. X is 3, y is 3 halves, it's just a coordinate. You're telling me, without graphing them, where those two lines cross. And it's at that point.
What would it look like?
So
I
where'd
want
you
the
get the
problem of
X?
X.
Wait, where'd you get the X?
No solution.
Do you get where we got the y? Did you get where we got the y from?
Yes.
We then took that and plugged it back in over here. So 2 times y gave us x.
Okay, you were going to that.
I apologize. What were you asking, George?
What would the problem look like if there were no solution?
We're going to look at one of those, just not yet.
How do you know that it's consistently independent?
Because it had one solution. If it actually gives you an answer, and that's actually kind of what you were asking, you're going to know when one of them is like one of those no solution or infinite solution problems, because everything's going to cancel and be like, where'd my letters go? Because everything's just going to cancel. But if you get an answer at all, x equals y equals whatever, then it's consistent independent, because that means it's one spot. Let me actually take this off the board and show you 3 and 3 halves. That was our answer, and that's where it comes from. You could have graphed that. If you wanted to solve for those for y and graph them, that's where they would intersect, which is the whole point of our lesson. Let's try another one. So which letter is solved for already? Y. So, here we go. Oh, hold on, before I get ahead of myself. If y is solved for, what are we going to do with it? What's the whole thing today? Sub it. We're going to take what y equals, bless you, and plug it in for the y in the other problem. So, that's going to be 3x minus 5y, but instead of y, I'm going to plug in what y equals. And that equals 15.
3x minus 3.
Yes. Uh-oh, I think this is one of that Gerard was talking about. Look what happens. 5 divided by 5 cancels. You're left with 3x minus 3x equals 15. What's 3x minus 3x? 0. Now, 0 equals 15. Is that a true or false statement? It's false. Now just think. False. Do you think that means we're going to have infinitely many solutions or no solutions? Very good. False statement means no solution.
If it said 15 and 15 would be many solutions?
Yes, it would. If it was 15 equals 15, a true statement, or 0 equals 0, which is what you'll get most of the time, then it would be infinitely many solutions.
What was that last problem?
Maybe what was it?
What was the last?
It was consistent independent. This one is, who remembers what no solution is? Yeah, but what do we, you remember what it was?
No solution.
Inconsistent. Inconsistent, that's right. If they're parallel, which is what those are, because it's no solution, then it is.
Used to writing that down.
Yes, you should.
Do we have to put the no solution?
I wish you didn't have to, but I'm going to tell you right now that on your tests that like are mandated for us to give you that I don't even make, there are going to be problems that say, like they'll give you this, and the whole answer will just be, is it consistent independent, consistent dependent, inconsistent? They'll probably give you inconsistent dependent just to see if you know what the heck you're talking about. But, yeah, you do need to get a hang of it. What did you say?
No.
Okay. So, let's just uncover this, but I guarantee you it either says inconsistent or no solution. No solution. Although inconsistent is the better way to remember it, but same thing. So, false statement, no solution. True statement, infinitely many solutions. Now, what I do to some classes that I am meaner to is I will give them problems where a variable is not solved for, just to make them solve for one, to use substitution. But I'm telling you, if you get to a problem on your test and there's not a letter by itself over here, that's not a good time to use this substitution method, because that just adds work for yourself. And I'll teach you how to solve those kinds of problems tomorrow. But today we're going to focus on problems where a letter is solved for, like this one. I want you to try to get started on this problem. Just see if you can get the first step. So, hopefully your first step was to plug 1 minus 4y in for the x on the other problem.
Miss J-Matt did say that she was taking stuff from the algebra book. So
Did she?
that's probably why.
Well, heck, at the rate we're going, we might get halfway through Algebra 2 before this class is over, and then that class will be easy. All right, so multiplying. 2 times 1, 2 times negative 4y. Let's see, so it'll be 2. Negative 8 plus 7 is negative 1y. Ew. Subtract 2. And you're left with negative y equals 1. Are we done with y? No. It has to be positive. So you can divide both sides by negative 1, or you could add the y and subtract the 1, whichever you want to do. And that'll give you y equals negative 1. Are we done now? What do we have left to do? Sub it, that's right, sub it back in. So if y equals negative 1, I'm going to plug that in right here, because x is already solved for in that second equation. You could really plug it into either one. It doesn't matter which one you plug it into, but if you've already got the other letter solved for, you might as well just plug it in there. So that'll be 1 minus 4 times negative 1 equals x. I just plugged negative 1 in for this y. So that's, let's see, 1 plus 4, was that 5?
Yep.
5 equals x. So our coordinate would be 5, comma, negative 1. Like that. And I'll give you a second to write that down before I uncover that box and see if we're right. Most of the time, if it works out that pretty, you're probably right. Normally you'll know if you're working it out wrong if you get something gross, like 37 over 79 or something. Ugh.
All everybody members report to the cafeteria for the meeting.
Alright, we're back. We're going to plug this in.
I know. I went to the game.
Alright, we're going to plug this in for y. 6x. Shh, y'all can talk about this in just a second. Minus 2 times 3x plus 2 equals negative 4. We're plugging this in for y on the other problem. Uh-oh! I wish Gerard was here. He'd get excited about this. So that's going to get 6x minus, minus 6x minus 4 equals minus 4, which is going to give us negative 4 equals negative 4 when the 6x is canceled. Is that no solution?
Or 0.
That's right. What is this? That's right. Consistent dependent or infinitely many solutions. If it's a true statement, it's infinitely many solutions, not no solution.
Our offense just looks so bad that our quarterback got taken out. And
You didn't score until he got taken out.
And then, yeah, but that was his fault.
Oh, I like your backup better anyway.
But no.
You people are obsessed with running quarterbacks. Yes.
He's sweet, but I mean,
Where do you get that negative 6x?
This one? Negative 2, because we still had the 2y. So there's the 2, and then there's what y was. Negative 2 times 3x is negative 6x.
So we do that plus 2.
We have to do the same thing. Negative 2 times 2 was negative 4.
Oh, that's right.
our defense was playing the whole game.
Listen,
They
drop
played
it.
them. They did
All right. So, just like we thought, it was infinitely many solutions. Questions? No.
I was wrong.
Keith, if it's a false statement like 0 equals 5, then it's no solution. But that one was negative 4 equals negative 4, which is true. So it's infinitely many solutions. All right, 12, 16, 20. That's 5 problems. You have like 20 minutes. There's no reason you can't get these done before you go. So I'm going to grade these before you go.
Why only give 5?
Do you want more?
Question? No, sure don't.
Oh, I need to stop the recording.
No, don't stop recording yet.